this is Hank, and in this video we're going to talk a little bit about how MathDog works and look at the code and some of the design effort that went into building it. We'll start off by doing a demonstration and then diving into the actual design code and see where you can find some access to it for yourself. So to get started, the way that I do my development for my Mac is I leverage an Alexa service built on top of a Raspberry Pi so that I don't have to get up and go into the main dining area where we have our actual Echo deployed so that we can use for the house. I can do all my development here from my desk where I've got the Raspberry Pi running the software sitting right on my desk. Makes it super easy. So let's go ahead and kick off and get MathDog started. We can also see over here on the side, this is an image from my phone, so we can actually see Echo or see Alexa as it processes each of these activities for MathDog. Open MathDog.
Welcome to MathDog, your personal math tutor. Are you ready to begin a game?
Yes.
What is 9 plus 6?
15.
Way to go. What is 6 plus 4?
10.
I didn't catch your answer. Please try again. What is 6 plus 4?
10.
Great. What is 8 plus 4?
12.
Well done. What is 8 plus 4?
12.
You got 4 out of 4 questions correct. You did so well. I'm raising your difficulty to level 2. Would you like to play another round?
No.
Great job today. Your skills are looking great. Come back soon.
Alright, so I went through and I played one round of MathDog through here. We actually saw an example of one of the things that I had to deal with in the code where I said the answer, and down here if we take a look at the actual feedback from Alexa, it was right here where she thought I said yeah when I actually had answered 10. One of the features I had to build into the software was that if an answer came through that wasn't quite clear, or Alexa or MathDog got back a response that didn't match the type of activity that it was looking for, MathDog would then ask and repeat the question back to get a good answer. Otherwise, what would happen is MathDog would just end in the middle of the games or shoot an error out, which is something you don't want your users to have to deal with. So now that we've seen it working, let's take a look at how I went through and process for some of the design. So the first thing I want to show and look at here is the actual kind of voice user interface design diagram that I built. Now this is the final version that kind of evolved over time as I designed and built out the software itself and made some tweaks through it. But before I ever did any coding, I actually started with a version that was fairly close to this. Now I wasn't able to find a good standard on how to build a VUI diagram, so I kind of went and did some of my own color coding and design options. As you look across here, each of these red boxes indicate intents or ways to access the program. So the launch intent indicates when someone asks to open MathDog. Start game indicates somebody asked to begin a game. You can see over here where we can set difficulty or we can ask for the difficulty menu. Each one of these red blocks indicate one of those intents and actions that will come through. Each of the orange blocks indicate a voice response that MathDog will issue back and then wait for the user to provide some feedback. Each of these circles with the waves indicate a point in time when Alexa is waiting for the user to provide feedback, and then we'll take action on those. And then the purple boxes indicate what's expected to come through for particular contextual actions. So in this case, if someone asks for the difficulty menu, MathDog will provide details on the difficulty levels and then ask the user, what difficulty level would you like? And they may say 3, 4, 5, 6. And that's the numeric response here. However, down here at the ask a problem phase, we also would get a number back. So this is one of the things we'll look at in the code is how do I deal with the same type of a response coming from the user, but depending on where we came from, whether it was they were getting a problem asked or whether it was the difficulty details, we respond differently. More than just the numeric responses are all the times where MathDog will ask a question that would be a yes or no answer. And then yeses are processed differently based on where we're coming from. For example, if you just open up the application, you're given a welcome message, and then MathDog will ask if you want to begin a game. If you say yes, then what will happen is that it'll go ahead and it'll start by asking your first problem. However, as you go through your game, if you finish your round, come up here and you're asked if you want another game. In this case, yes will take us back to take us back into a game for the next round, and then no will take us to goodbye. All of these areas and creating this design really helps understand in my head as I'm doing the design and writing the code, where do I have to go? What is the expected flow of the application to go through? And what we'll see as we move from the design here and into the actual code, where each of these blocks represent different functions or different aspects of the program that's in place. Now we can see here where I'm working on the actual code and I have the MathDog Python file up and running. Now I actually run this code inside of AWS Lambda. It is the easiest way to actually run functions. You don't have to deal with any of the security services, and then through the AWS service it'll dynamically spin up and take advantage or make sure your program's available every time a user accesses one of your skills. Definitely a great way to get started with writing skills for Amazon, and all of the examples and tutorials that Amazon provides you uses Lambda as the backend service. So a couple things to note is I've come up with a kind of a pattern as I build out the skills. I always start out with a set of helper functions, which actually came from most of this code here, which is where we actually build the responses that the Lambda function will send back to Alexa to issue the voice responses and ask questions of the user. These came pretty much directly out of some of the tutorials and sample code that Amazon provided as I got started. I made some tweaks and adjustments as I've gone through. This next chunk is where the actual processing of understanding the initial request from Alexa's service, the Alexa skill service coming in, will be addressed. The Lambda handler event is where we actually go through and see what type of an event came through. And the most common ones are launch requests, and this is just where a user says, open MathDog. That's a launch request. The intent requests tie back to the actual activities or questions or directives that the users have provided. Back on our voice diagram over here, each of these red blocks represent an intent that would be coming in. And we'll see as we go through here that how we process each of these intents differently in the onIntent request function we'll look at in just a moment. Down here, the session ended request is how we actually clean up and we close down a particular session cleanly after a game is finished. Now the most interesting one is this onIntent request here. This function, which is located here in the code, is where we actually process and understand what do we do with the different types of activities that the users may be asking. Now if we look through this set of if, elif, and then else loops, we can actually see where we're processing them through. I start out with some of the default, the Amazon included intents that will come through. You want to make sure that you have support in your program for if a user asks for help, if a user says to stop or cancel, which are two different types of activities as far as Alexa is concerned. And then underneath that is where we start to get into some of the actual intents that were defined by me. So this intent difficulty menu corresponds to this intent over here, where I can see that I spelled menu incorrectly. Let's go ahead and fix that now. So if a user asks for difficulty menu, and that's where they come into the application, that's this portion of the code is what is going to execute, and we'll look at what that does in just a moment. Other ones set difficulty below this, so the difficulty menu gives the user information about how to set the difficulty, what are the different levels that are out there. And then when they're ready to actually set the difficulty, represented by this red block in our voice diagram, we will then process this type of an intent that comes through. Similarly, for setting round length, we would do the same thing. Now to actually start a game or ask the next question, here we can see that we've got the intent name for start game. Some of the more interesting ones we'll look at down here are the numeric response and then the yes/no intents. These intents on their own, a user saying the number 7 or 17 or simply giving a yes or no answer, depending on what the question was asked, wherever MathDog was in its processing, that'll determine what type of an activity we actually have to take. So we'll look at in here how we actually consider where did the user come from in order to make sure we take the proper action. Underneath that block of code is where we get into the actual functions that control the skills intents themselves. And we've got messages here that for roughly will correspond to each of the yellow blocks or the orange blocks representing responses that Alexa may be asking on behalf of MathDog. So the welcome message response from a launch intent is this function here for get welcome response. Whenever they're asking a question, whether it's the next question in an ongoing game or starting a new game, that'll be the play game function. Repeat question is a function I had to add in for those cases where Alexa wasn't quite sure what the answer the user gave. Didn't quite sound like a number. We thought maybe they said a yes or no or a cancel, and we just need to ask the user again to get another chance to go through. We can see our Get Help menu so that when users ask for help, and then difficulty options, both to provide a difficulty menu as well as to set the difficulty, and then so on as we go through. So let's take a look at how some of these processing might go through as the user opens up and interacts with MathDog. So we'll start out with a user comes through and does the Open MathDog or Start MathDog. That'll execute the launch intent. So if we take a look at what the program is going to do, so here on the onLaunch event, we'll expand that code out. Oops, expand it out more than I meant to. So if we expand out that function, we can see that the first thing that it does is it just prints a statement into the Lambda log, indicating that a new request has started. And this is really useful for troubleshooting as you're trying to make sure that your skills are taking the activities that you wanted. And then the next message, what we do is we return back the results of the get welcome response function. So let's go take a look and see what that function does. In this function, the first thing we'll do is, you'll see this repeated over and over throughout the code, is that we set up the card title, the text, and then the speech output. So all of the information that's going to be necessary for Alexa to actually provide feedback back to our users. The card title here represents the actual information that Alexa is going to show inside of the app or on the web page. So if we flip back to the view that I had on my phone, where we can see the actual welcome response or the launch request is right here. You can see I've got welcome to MathDog, subject of MathDog is the skill that it came from, and then welcome to MathDog, your personal math tutor. Are you ready to begin a game? This are you ready to begin a game is how we actually prompt the user to give us the next possible action that goes through. Back in the code, we can see here's the actual text that went through. So the card title, the information that the user was going to receive both in the card as well as what was spoken. And then we use the SSML formatting language, the markup language here for speech. So we tell Alexa that we want to speak the text variable that's here, and that's what's going to be sent back. Once we do the get welcome response and the user is asked, are you ready to begin a game? If we assume that they come back with a yes, like we did in the example at the start of this video, what will then come back through is we'll end up with an intent request of start game, which is located here. What'll happen through the start gameplay here, but at the very beginning what we do is we kick off the return play game function from below. The play game function is where a lot of the logic and kind of the heavy lifting of the application actually happens. I'm going to keep most of this code folded up so that we can highlight some of the key areas as we go through. The first thing I do in this function here is we set up all of the information and the variables and the placeholders that we're going to need as we go through. So again, the card title, the text, the speech output, reprompt text, those are fairly standard for any kind of skill that you're building. There's some here specific to MathDog. Encouragement is a field that I use that if a user gives back a proper answer, a good answer, a correct answer, we'll give a way to go or great job. If they provide an answer on the previous question that maybe was incorrect, we give them some encouragement that says you'll get it next time, or keep up the good work, or one of those pieces just to indicate and keep them going so that they know where we went through. A couple of placeholders for the last question and the next question so we can check and make sure that the answer that was provided was correct on the previous question, and then get ready to give them the next one as it goes through. All right. In this area here, starting with the if we'll be asking a new question, let's go ahead and get a question. This is where we actually go and we use the Python code to actually generate a question at random based on the current difficulty level. If we're in the middle of a round, or they're at the or as long as we're not at the end of a round, we'll go ahead and we'll get the next question using the get question function below. The get question function goes and checks the difficulty level and then finds an appropriate operation, addition, subtraction, multiplication, or division. And then once we have that, it creates a random question and then passes that back up so that we can actually format the response back to the user to ask them the information. We store all the question details as well as difficulty levels and other settings about a particular session in the session attributes value, which is just part of the information that's passed back and forth from the Alexa service to the Lambda function that goes through. And it's how we maintain any kind of state between questions, information and response between the user and Alexa service. at its heart, the Alexa service is not stateful. We don't keep track of that automatically. So it's up to the programmer to make sure that we can track that as needed as we go through. So in this case, we get the question, and then we update the detail that goes through. Down here, we can see where we actually set up the card text. So we provide the encouragement. We tell them, great job if they got the or if their last question was correct. We say, keep up or you'll get it next time if they happen to miss their last question. We put in the next question text that was provided back by the getQuestion function. And then in the speech output and reprompt test is how we actually say what the users are going to hear and then go through on that spot. And then each function here that is going to actually provide details back to Alexa's skill ends with a return function that uses the build response. And this was code that was provided as part of one of the example applications that Amazon provides on their documentation at developer.amazon.com. So that kind of walks us through the general function in the play game capability or area here. All of the other functions, whether it's getting help, setting the difficulty level, all of these areas kind of follow that same functionality. Now, I'm not going to walk through all of the code here on this video. It's all posted on GitHub. So if we go over and we'll actually take a look at the repo. Over here on GitHub, underneath the Brown Dog Tech Organization, we can see that we've got the MathDog code posted. Now, all the code for MathDog as functioning in the live application in the skill library is posted here on GitHub for your use. In addition to that, in addition to the code is the VUI diagram that actually shows the processing that goes through on here. I've stored the JSON file that shows the intent structure that Alexa uses to actually understand what types of requests users may be giving us, and then the sample utterances that go through to process what users may be, the phrasing that users will go through. Let's take a look at that file here. So if I click on the utterances text, you can see that we've got each of the intents that require the programmer to identify what are the words or what is the phrasing that that MathDog is going to expect will come through. So to open up the difficulty menu, any of these options would be appropriate. Change difficulty, change level, difficulty. Just saying the word level will execute the difficulty menu. Once we want to set the difficulty, we can either set difficulty to number or set level to number. We'll execute those. Setting the round length will indicate how many questions each round of MathDog will go through. So we've got options there on how to set those. And then all the different ways to start or begin a game. We also support the numeric response intent here, which is where a user just provides a number. Now if we go back, and I mentioned this before, if we look at the actual numeric response, we can see that I've got some if and then an else if embedded in here. And it's all about keeping track of what that numeric response would be coming back from. So if a user gives a number, let's say the number 5, and the previous place was stored that they were at the difficulty menu, we know that they're trying to set the difficulty level to 5. However, if the previous place they were at was ask a problem or play a game, this indicates they're in the middle of an actual game, and the number 5 indicates the answer, or their provided answer to a problem on that. So we can process those appropriately. Similarly, for the yes and no intents, I've got functions in here to track where they may have come from to provide the yes answer or the no answer. So a yes response for set difficulty, get help, welcome, play game. Each of these are areas where the MathDog may have asked, do you want to play a game or do you want to continue? A yes response from there will send us down the game path. However, if they get to the very end of the function, or if they try to end midway, and the previous place was, hey, are you sure you want to end the game in the middle? And they provide yes to that, then we'll end the game appropriately. This is one of the things that was new for me as I built out MathDog compared to some of the other skills that I've created in the past. This level of complexity and understanding what the user meant based on where they were in the application was something that I had to figure out how to deal with effectively. And tracking this previous place as part of the session variables was the trick that I came up with to keep track of that. And it seems to work very well. All right, the last thing I want to show in this video is how the code actually comes from my laptop here, or on my computer here where I'm writing it, and then on GitHub where it's actually being stored, to turn it into a functioning skill. This starts in developer.amazon.com. So here under Alexa, we can see the Alexa Skills Kit. We can see in here where I've got all my skills. I've got 2 others in addition to MathDog that are currently live in the system, and then I've got a couple that I'm working on for some different projects. Here in MathDog, if we take a look at here, we can actually see how these are set up inside of inside of developer, or we can see how these are set up inside of Amazon so that we can publish them out. So each skill gets a name as well as an invocation name. The invocation name is what the users will say to their device to get them started. In this case, it's MathDog. The interaction model defines all of the intents and the potential, the different utterances that would, and an utterance is just what the users are saying, remember, that would execute certain actions on there. Here in configuration, we can see that we're pointed to a Lambda ARN number, Amazon resource name, the other option being HTTPS if you're going to host your application on your own service. The Lambda number that's indicated here is the actual function in my console that's running the code that we've been looking at. So if we flip over to AWS, we can see that I've got my Lambda functions that are written. Each of these are supporting a different service. And underneath MathDog, here's the code. Exact same code that we're looking at on the other side we were looking at earlier. Underneath configuration, we indicate that it's a Python function, that we're doing Lambda capabilities. Here we can see that it's an Alexa Skills Kit that's going to run the code that we went through on that. For this case, the code that I written here in Python is fairly simple, doesn't require any external packages or libraries. I didn't have to upload any sound files or resources to be used as part of the application, which means I could just copy and paste the exact code directly up. In many cases, you may actually have other files that have to be included, in which case you would upload a zip file of your to Lambda rather than copy and pasting the code in. That's enough for here. If you've got any other questions or how this works, feel free to add a comment to the video or add a comment to the blog post, depending on where you found this video post, and I'd be happy to answer more questions on that. See you next time.